Our first example is an algorithm that prints the numbers from 1 to n. This is a very simple problem, and the algorithm for this problem, as you will see, is very simple. The purpose of this problem is to show you how to represent the algorithm using a pseudocode, and also how the same problem can be solved with different ideas and methods. At this level or moment, I assume that you already know a computer programming language like Java, C++, or Python, and you know the difference between iterative methods and recursive methods. Iterative methods, it means you use loops for solving the problem, and recursive methods, it means you use recursion to solve the problem. Our first approach or algorithm will be using iterative method, and this algorithm we're going to describe it using words. Here we assume that we already have the value of n, which is a positive number greater than or equal to 1. Now to print the numbers from 1 to n, we need a variable that prints the number from 1 to n iteratively. So let us write these steps. Now in step 1, we will assign the first value that we need to print, which is 1, to a variable, and we will call this variable I. Step 2, we are going to test the value of I against n. So we will say if I is less than or equal to n, then we need to go to a step that prints the value of I. So simply, which is the next step. So we will say go to step 3. Now, what if the condition is false? That means we don't have any more numbers to print. So this is the end of the algorithm. So here we will say else, go to step, and then we need to know what is the last step. We will specify it here. Now in step 3, if the condition at step 2 is correct or true, then we need to go to the next step, and in the next step we print the value of I. So here we will say print the value of I. We need to update the value of I for the next number. So we will say add 1 to I. And in step 5, we need to go back to step 2 for testing the new value of I against n. So we will say simply go to step 2. Now in step 6, which is the last step, this is the end of the algorithm. We will say simply end as an indication, end of the algorithm. And at step 2, if the condition is false, we will go to step number 6. So these are the instructions for printing the numbers from 1 to n iteratively. It is not preferable to describe the steps of algorithms using words because they might introduce ambiguous instructions or operations. Therefore, we're going to use pseudocode. The instructions in the pseudocode resembles the instructions in a real programming language with slight differences. So let me show you how to do this. As you notice that in these steps, what we have is simply a for loop. In this for loop, we have a variable I that iteratively goes over the numbers from 1 up to n. So how do we write the for loop in a pseudocode? As you will see later, that for any algorithm, we need to assign a name for this algorithm and what will be the input for this algorithm. So let us start giving the algorithm a name. So we will proceed it by the keyword algorithm. We give it a name, so we will call it a print number, and it will accept numbers, print numbers, and it will accept the last value because we need to print the numbers from 1 to n as a parameter, so n will be the parameter. To write for loop in a pseudocode, we write the keyword for, and the variable that we will use for this for loop will be I. So we need to assign this first value to I. So we say I, we use a left arrow and we write 1. So we will say for I equal to 1, to the last value in the loop, which is n, do. So here in pseudocode, we don't specify how the value of I will be updated, because it is implicitly updated by 1, by adding 1. So therefore, you just write it like that. After each iteration, the value of I will be increased by 1. So inside the loop, what we want to do, we want to print the value of I. So we will call a method or a procedure that is responsible for printing any input parameter that is supplied to it. So we will say print, and we want to print the value of I. And that's it for the algorithm. So how to use this algorithm? In another place, like for example, in a main program, to call this method, simply you write the name of the algorithm, print numbers, and you supply a parameter. Suppose we want to print the numbers from 1 to 10. So you can supply 10 as an input parameter, and the algorithm will print the numbers from 1 to 10. Our next approach for solving this problem is using recursion. But before we write the algorithm for this simple problem, we would like to have a quick review on how recursion works in general. So let us assume we have a problem, and the solution for this problem is represented by the algorithm that is called Pn with a single parameter n. Conceptually, we will look at the algorithm as a box containing the statements of this algorithm, and for every recursive call, we have another box containing the same statements of the algorithm. So here is the box for the algorithm, and the statements for the algorithm will be the content of this box. So when do we say that we have recursion? We say that we have recursion if one of the statements of the algorithm is calling the algorithm itself. So let us assume that the algorithm is calling itself by the statements Pn, and here we will assume that for the next recursive call, we will supply the same input parameter that has been received by the algorithm. This is not a good design. Why? Because we are calling the same method with the same parameter, so the recursive call will never stop. There are some statements before the recursive call, and there are some statements written after the recursive call. We will call the statements that are written before the recursive call, we will denote them as a pre-work statements, and those written after the recursive call will be denoted by post-work statements. So since we have a recursive call, we will make another copy of the box, and we assume that the contents of this box will be the same statements of the algorithm. In reality, there exists only one copy of the algorithm in the memory. Whenever we have recursive call, then only the local variables and the parameters are saved on the stack. They are pushed on the stack. And whenever we return back from the method, just before returning from the method, those parameters, the local variables, and the parameters are popped from the stack, loaded back, so that the previous recursive call can resume execution. So since here we have recursive call, so that means we have many copies of the box representing the same algorithm. We have many copies, and in every algorithm it is calling itself. I will use different color. So here the algorithm is calling itself, so it's going to the next box, and here we have the recursive call going to the next box. Here we have the recursive call going to the next box, and so on. It will never stop. Notice that the pre-work statements are executed immediately when we enter the algorithm, and the post-work statements are postponed or suspended. They will be executed whenever we return back from the recursive call. Why we are mentioning this? Because if we want to print the numbers from 1 to n, you need to specify where to print the value of n. Is it before the recursive call or after the recursive call? Now, as you can see that the recursive call is not stopping. Why? For two reasons. The first reason is that the value supplied for the next recursive call is not changing. The second reason, even if it is changing, where to stop it. If it is increasing, then you need to specify what will be the upper bound for stopping, And if it is decreasing, we need to specify what is the lower bound for stopping. So therefore, in general, if you want to design a recursive algorithm, you need to attach the recursive call with an if statement. And the condition for this if statement will be the stopping condition. Let us apply this on our problem. So we want to print the numbers from 1 to n. So for the next recursive call, what will be the value we need to supply for n when we receive the value of n? So now if we receive 5, do we need to print it now immediately, or we need to wait? Because 5 will be the last number printed. It will not be the first number printed. So therefore, we should not immediately print it when we enter the algorithm. So we will not have anything in the pre-work statement. Printing will be in the post-work. So here we will say print n, and here we will say print n, and here we will say print n, and so on. Print n, print n, and so on. But again, the value of n is not changing. So again, we are printing 5, and when we return back here, we will print 5, 5, and so on. Since the numbers from 1 to n, the difference is only 1, so we need to decrease the value of n for every recursive call by 1. So therefore, here we will say we have n minus 1, and here n minus 1. So here n minus 1, n minus 1, and n minus 1. So when this method receives the value 5, it will supply 4 for the next recursive call. And when this method receives 4, it will supply 3 for the next recursive call. And this method will supply 2 for the next recursive call, and the last one will supply 1 for the recursive call. Notice that the numbers we have 1, 2, 3, 4, and 5, and the first number we want to print is 1. So we need to stop the recursive call here and print 1 and then come back. When we come back, the value of n is 2, so we will print 2, and when we come back, the value of n is 3, we will print 3, and so on. So the conclusion is that if you want to design a recursive algorithm, think about if statement. The condition for the if statement will be the stopping condition, and the body of this if statement will be the recursive call. Now let us write the pseudocode for the algorithm. We will design our algorithm first by using if and else statement. Then we will design it using a single if statement. So we assign it a name. So here we will say that we have an algorithm. And the name for this algorithm will be print numbers with a single parameter n. As we discussed before, that for recursion, you need to write if and else statement. For the if statement, you will specify the stopping condition, and for the else statement, you write the recursion. So here we will say that if n equal 1, so this is the stopping condition, which is the first number we need to display. In this case, don't call the method recursively, simply print the value of n. And notice that the value of n is 1, so here if you write 1 or you write n is the same. Next, for the else statement, here you write the recursion, or here you write the statement for the algorithm to call itself. As we discussed that we need to print the value of n after we return back from the recursive call. So here we will call the method recursively, so we will say print numbers, and we will decrease the value of n by 1, and then after returning back we will print the value of n. So now how to call this algorithm from, let's say, a main method or main program. So here we say main, and we call the method or the algorithm by saying print numbers. Then we supply a number for n, and the algorithm will print the numbers from 1 to n. So let us assume we want to print the numbers from 1 to 10, so we will supply 10 for the value of n. And then the algorithm will receive 10 and will call itself recursively. At the end, it will print the numbers from 1 to n. Now the next design for the algorithm will be using single if statement. So we will make a slight change to the algorithm. So we will say algorithm, and we will give it the same name, print numbers, and n will be the input parameter. So we are not going to write if and else, the if condition for the stopping condition and else for recursion. We will write only a single if statement. And the condition for this if statement, remember that we will use if for calling the method recursively. So the body of the if statement will have a statement for the algorithm to call itself. So the last number that we need to reach for n is 1. So as long as n greater than or equal to 1, then you can call the method recursively. So here we will say print numbers, and the input parameter will be n minus 1, and then we print the value of n. Notice that for the condition here, also we can say that n is greater than 0. So the last value for n will be equal to 1. So what's the difference between the two pseudocodes? For the first one, we were using if and else. For the second one, using single if, is that for the if statement or single if, we are going to have extra recursive call. Notice that when n is equal to 1, for if and else statement, it will stop the recursive call. But here, for single if statement, if n is equal to 1, so we need to call the method recursively with n equal to 0. And when we enter the algorithm with n equal to 0, the condition is false. Therefore, there will be no recursion, and we exit the algorithm. Here are the two solutions for this simple problem. The first solution using iterative method, and the second solution using recursion. Now, what if we want to print the numbers from n down to 1 instead of printing the numbers from 1 to n? So what changes we should make for both methods? Now, for the iterative method, the same for loop will be used, but instead of counting up, we will count down. So how do we do that? So we write an pseudocode for I starts from n down to 1. So implicitly, the value of I will be decreased by 1. Now for the recursive method, the only difference is that instead of printing the number in the post-work area, we print the number in the pre-work area. So notice that the previous answer, we are printing after we return from the recursive call. But now for printing the numbers from n down to 1, we print the number before we call the recursive method.